All right, hello and welcome. In this example, we are going to determine the time constant for the following RC combinations. So the RC time constant is your resistor multiplied by your capacitor. Right, and our time constant is going to change dependent on what type of calculations we're working on. So if we have inductors in the circuit and resistors, that's going to be one time constant. But if we have capacitors and inductors together, that's going to be a different time constant. So there's going to be 3 total ones that we work with. And they are involved in our frequency calculations. So you got to keep them in the back of your head as you're looking at some of those new frequency calculations because they're going to relate to the time constant. So time constant is our charge time. Our resistor slows down the amount of time that we can charge our capacitors. And so we will see that these are going to be related to each other by a multiplication. So we are going to multiply these two terms together here and get our time constant in seconds, right? The charge time. So to do that, we'll take our resistor. We'll say that that is 2.3 times 10 to the positive 3. We'll multiply that by 550 times 10 to the negative 6. And we know immediately that we can kind of resolve out our exponents. If we're going to multiply exponents, then our exponents value up here is going to add together. So we know we're going to be in milli. Right? So if we take a positive 3 and add a negative 6, we end up with a negative 3. And so whatever our answer is, it's going to be times 10 to the negative 3. Right? That means that we can just multiply our two base numbers at the beginning and get our magnitude. So we'll say that we have 2.3 times 550. So that is 1,263. Times 10 to the negative 3, which means that we're in milliseconds. So we can move it forward, right? If we're right here, or 1, 2, 3 forward, that gives us 1.26 seconds. It takes 1.26 seconds to charge that capacitor. It's a long time. Right, so we're going to do a couple more of these. For this next one, we're going to skip a few of these here and just kind of move into typing it all into our calculator, right? Because we can type them fully into our calculator as well. We don't have to match them or anything like that. So we'll take these next two and say that we were given 2 million. So 2 times 10 to the positive 6. And that is multiplied by our 2,800 picofarads. So 2,800 times 10 to the picofarad, that's negative 12. And so we'll use that there. We'll say that our time constant is really small. It's in base right now, so we can move that back 1, 2, 3 spots and get 5.6 milliseconds. Right? Last one was in seconds. It took over a second that time, right? But this time right here, it's going to be in milliseconds. All right, we'll do our last one here. This last one takes a 100 or 120 ohms and compares it to a 20 nanofarad. And so we'll send this one out and we'll say that we have 120 multiplied by 20 times 10 to the negative 9. To the negative 9. And that gives us a microsecond. So we'll leave it just like that. We'll say that we have 2.4 times 10 to the negative 6, which gives us our microseconds. All right. Let us know if you have any other questions.